Okay, so we continue and we see in the second step we have done. Now we go to the column 1. Now what we are doing, we are just adding the column 1 and column 2. Okay, in the column 1, sorry, we are I said column, I'm really sorry. I mean we have to add the step 1 and step 2. Okay, in step 1 we saw that the number of lopping points to introduce one in the pivot column or the first entry, we needed n multiplications. This is another term for the division. And also similarly we saw that to introduce 0 below this first column, we needed 2n into n minus 1 flopping points, right? To sum up this first and second step, so how many total number of flopping points we needed to introduce below the first to introduce 0 below the first column, that where we have to add first and second step. So when you calculate this you will get 2n square minus 1, right? Now we go to the column 2. Okay, now you have to focus here. The procedure for column 2 is same as the column 1, except that now we are dealing with the one less row, okay, and one less column. The same procedure we have to repeat, but what we have only one less row and one less column. Thus the number of flops required to introduce the leading one in the second row in the 0 below it can be obtained by replacing n by n minus 1. And the flop count for the first column, we have to do the same, only just we have to separate one. Thus, the number of flops required in column 2 would be what? Just just put in the place of n, we have to just plug in n minus 1. So remember from the last step we have 2n square minus 1. We have to just plug in the place of n. We have to just plug in n minus 1. So I have put here, that is 2 times n minus 1 whole square into minus n minus 1. Similarly, by argument for column 2, the number of flops required for the column 3 are how many? They are, we have to just plug into 2 less, so it would be what? 2 times n minus 2 whole square and difference n minus 2, right? Okay, now let me go down, scroll down and see what do we have. Now, if you go in this way up to the end, what will you get? 2n square into n, and 2 times 2n square minus n minus 1. Similarly, 2 times n minus 2 whole square subtraction n minus 1, all the way up to the final result or the final entity. Okay, that you go up to the 2 minus 1 up to the end. Okay, we can rewrite this element. If you rearrange this one, then you can rewrite this one as, if you take common from these all the things, then you will get 2. Okay, then 2 times n square into n minus 1 whole square all the way up to the end, and minus n into n minus 1 plus so on up to the 1, right? Now, if we apply the formula number 1 and formula number 2, okay, remember the sum of square of first natural number is what we are going from n to the from starting to the end. But here we are writing. You can rewrite this from starting to the end. It would be what? It's a 2 times to keep 2 aside, only apply the formula of square of first natural number on this part. You will get n into n plus 1 to n plus 1 upon 2, and subtract n into n plus 1 upon 2. When you simplify this you will get a result 2 upon 3 n cube, 1 upon 2 n square, and minus 1 upon 6 n, right? So this is the process for the, this is a process for what? It's a process for forward forward substitution. Okay, to this is a process to make the upper triangular. Okay, forward substitution, you can say. It's a forward process we have done with. Now we have to do the backward process also. So let me go up and show you that process also. Okay, so now we focus on the back substitution. Now you can see it's look like this one. Okay, so remember from the process that you did in your premier classes, that we, after doing the first you can say process, we get the somehow upper triangular matrix. Okay, and the one in the leading diagonals. So what do we need to do here in the nth column actually? So in the nth column, we are in the nth column. So it requires n minus 1 multiplications and n minus 1 additions to introduce 0 above the leading one in the nth column, right? So what do we need to do? We need to introduce here what? We need to introduce here zeros. Okay, to introduce 0 above the first what in the last column, in the nth column, to introduce above the zeros of the last entity, that is, you can call it a nn. Okay, that we have made one. So introduce the zeros above this is the entire column. So how many multiplication do we need to use? You can think about it. We need n minus 1 multiplications, right? Because how many rows are there? There are n rows. Okay, and this you have to multiply. You have to multiply this entity. For example, this entity is, for example, b. Okay, so you have to multiply what? B with Rn, B with Rn. Then you need to add with Rn minus 1. Okay, so when you multiply B with Rn, so accept this element, how many times you have to multiply? You have to multiply with n minus 1 entries. Okay, similarly, you need to add n minus 1 times. Okay, so how many times do you need you need to do multiplications and additions, because here are n minus 1 rows, so you need n minus 1 multiplications plus n minus 1 additions. Okay, so for the in the last column, to make the its above entry 0, so in summary you need 2 times n minus 1 flopping points, right? Okay, now let me go to the next point, that is what? In the n minus 1th column, like this column. Okay, so you need to do what? The procedure is same as the step 1, except now we are dealing with one less row. So the number of flops in the n minus first column is 2 times n minus 1. You just need to reduce 1. Okay, and if you keep this process, so you have to just think how many rows are there actually. So you have actually you have to repeat this process up to the n minus 1 time. Okay, so how many rows are there? There are so in the column n minus 1 column, the number of flops is n minus 2, so it would be 2 times n minus 3. You have to reduce 1 only. Okay, so the total, when you are going to do its total, it's a 2 times n minus 1, 2 times n minus 2, all the way up to the end. So it's just when you take 2 common, so it would be 2 common, and if you see what you will have, the time is going to end. So I continue in the next video.